Section 2.6, rational functions and asymptotes. First type of asymptotes we're going to talk about are vertical asymptotes. To locate a vertical asymptote, set the denominator equal to 0 and solve after the expression has been simplified. Any factors that cancel out, when the expression is simplified, you put holes in the graph at those values. So the first thing you are going to do to identify a vertical asymptote is you're going to factor the rational function. If any of the factors cancel out, that is where you're going to have holes in your graph at whatever values make that expression equal to 0 for whatever cancels out. Whatever is left, you're going to put whatever is left as far as variables in the denominator, you're going to set that denominator equal to 0, solve that, and that will be where you have a vertical asymptote. Horizontal asymptotes. To determine where a horizontal asymptote occurs, compare the degree of the numerator to the degree of the denominator. When you compare the degree of the numerator to that of the denominator, one of three things can happen. The degree of the numerator could be less than the degree of the denominator. If that's the case, then the horizontal asymptote will always be the line y equals 0. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is given by the line y equals the ratio of the lead coefficient of the numerator over lead coefficient of the denominator. And the third possibility is that the degree of the numerator is greater than the degree of the denominator. And if that's the case, then there is no horizontal asymptote. So one of those three things has to happen every single time we have a rational function. The degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is always y equals 0. If the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is given by y equals the ratio of lead coefficients, numerator over denominator. Still going to be a horizontal line. Third thing that could happen, if the numerator degree is greater than the degree of the denominator, then there is no horizontal asymptote. So determine the domain, all asymptotes, any holes, and all intercepts of each function. Okay, first thing we are going to do is identify the domain. The domain you need to identify always from your original function. So in this case, do we have the possibility of a domain restriction? Yes. We have a variable down in the denominator. We know that that creates a possible restriction because any value of x that makes that denominator 0, this function will be undefined. So how do we find the restriction? We take the denominator, we set it equal to 0, and we solve. Take the square root, we get x cannot be 2, x cannot be negative 2, so our domain is from negative infinity to negative 2, negative 2 to positive 2, and 2 out to infinity. So the two values x cannot be are negative 2 and 2. There's our domain. Next, and you can kind of look ahead here and see that nothing's going to cancel as far as factors goes, but always get used to factoring, and it's going to help in everything else you need to do anyways. X squared minus 4 does factor as x minus 2 and x plus 2. We can see that there are no factors that cancel. Anytime there are no factors that cancel, that guarantees you that your graph will have no holes. So we know this graph would have no holes. Next, let's find our asymptotes. Let's start with vertical asymptotes. Vertical asymptote, we take the denominator and we set it equal to 0. What values, when we take x minus 2 and x plus 2 and we set it equal to 0, we're going to have a vertical asymptote at x equals positive 2 and x equals -2. Horizontal asymptote. Horizontal asymptote, we need to look at the degree. Degree of the numerator is degree 1. Degree of the denominator is degree 2. So the numerator is of less degree than the denominator, so our horizontal asymptote will be at the line y equals 0. The last thing, find all intercepts. Let's start with x-intercepts. To find an x-intercept, we know we plug in 0 for y, so we get 0 equals 2x plus 1 over x squared minus 4. And now pay attention to this because this is going to be the case anytime you have a rational function. To begin solving this for x, the first thing I need to do is get rid of the fraction, so I'm going to multiply by x squared minus 4. And notice what happens. Because we're plugging in 0 for y, and I multiply by x squared minus 4, 0 times anything is just 0. And we're left with the numerator set equal to 0, which will happen every single time that you have a rational function. So now solve this equation for x. We get x equals -1/2, which means our x-intercept then is at the ordered pair -1/2, 0. Find a y-intercept. Y-intercept, we know we plug in 0 for x. When I plug 0 in for x here, up top I'm left with 1. In the bottom I'm left with -4. So our y-intercept is the ordered pair 0, -1/4. Letter B. Start with our domain. Given variable in the denominator. Set the denominator equal to 0. This time x can be anything but 2. So our domain is from -infinity to 2 and 2 to infinity. Factor. Can we factor this polynomial? Either the numerator or denominator? No. Since it is not factorable, we can clearly see no factors are going to cancel. That tells us right away that this graph, again, is going to have no holes in it. Vertical asymptote. Find a vertical asymptote. We set the denominator equal to 0. X minus 2 equals 0. Solve. There's our vertical asymptote. Horizontal asymptote. This time we have a degree 1 polynomial over a degree 1 polynomial. The degrees are equal. When the numerator is of equal degree of the denominator, we look at the ratio of lead coefficients. 2 over 1, that is where our horizontal asymptote is going to be at y equals 2. Intercepts. X-intercept first. Remember when we plug 0 in for y, we're going to multiply by that denominator. It's gone, and we're left with the numerator equal to 0. We get x equals 5/2. So our x-intercept is at 5/2, 0. Our y-intercept, plug in 0 for x. Up top, we get -5. In the bottom, we get -2. Simplify that, and our y-intercept is going to be at the ordered pair 0, 5/2. Letter C. Domain first. Take the denominator. Set it equal to 0. Solve. X cannot be +1 or -1, which means our domain is going to be from -infinity to -1, -1 to 1, and 1 to infinity. Asymptotes. Before we identify asymptotes, factor x plus 1 over x plus 1 times x minus 1 when we factor that difference of two squares. And now we can see our x plus 1 factors are going to cancel out, and we're just left with this. Since we had a factor that cancels, that tells us we are going to have a hole for this graph. The hole will occur at the value that makes the canceled factor 0. So in this case, we're going to have a hole at x equals -1. Vertical asymptote, now we take our simplified expression right here, set the denominator equal to 0, and we also have a vertical asymptote at x equals +1. Horizontal asymptote is going to be at y equals 0 because the numerator is of less degree than the denominator. Finally, intercepts, x-intercept. Set the numerator equal to 0. 1 equals 0. That means there is no x-intercept. Y-intercept. Plug in 0 for x. We get 1 over -1, which means we're going to have a y-intercept at 0, -1. Letter D. Same process. Let's find domain first. Find the domain, take that denominator, set it equal to 0. We get x equals 3/2, so our domain is going to be from -infinity to 3/2, 3/2 to infinity. Go to factor this. We have a greatest common factor in the denominator of 2 that we can pull out. Nothing's going to cancel, though. Since nothing cancels, that tells us that there are no holes. Vertical asymptote. Set that denominator equal to 0. X equals 3/2 is where we have a vertical asymptote. Horizontal asymptote. We have degree 1 over degree 1. So we look at a ratio of the lead coefficients, 2 over 4. 2 over 4 simplifies to 1/2. So there are no holes. Vertical asymptote at x equals 3/2. Horizontal asymptote at y equals 1/2. Intercepts. X-intercept. Set the numerator equal to 0. 2x plus 5 equals 0. X is -5/2. So -5/2, 0. Y-intercept. Plug in 0 for x. When we put 0 in for x, we're left with 5 in the top, -6 in the bottom. So we have a y-intercept at 0, -5/6. Last one, E. Start again with the domain. Take the denominator. Set it equal to 0. X can't be -1. So our domain is from -infinity to -1 and -1 to infinity. Nothing factors here, nothing cancels, so we know there are no holes. Vertical asymptote, set the denominator equal to 0. X equals -1. Horizontal asymptote, we have a degree 2 polynomial over degree 1. Numerator is larger degree than the denominator. Anytime the numerator is higher degree than the denominator, there is no horizontal asymptote. Intercepts. X-intercept, we set the numerator equal to 0. Solve, we get x to be 0. So 0, 0 is going to be our x-intercept. Find our y-intercept. Plug in 0 for x, we get 0 over 1, which is 0, and there's our y-intercept as well. Okay, so that's all you're going to be doing in section 2.6, and this leads into what we're going to be doing in 2.7. You're going to have to do all of this stuff that we are doing today in 2.6 to be able to graph rational functions, which we will get into in section 2.7. So this is all the preliminary work that you need to be able to do in order to be able to graph a rational function.